Hello everybody. This is a presentation that provided to the 2018 Joint Conference on Industrial Engineering and Operations Management on the Team Process Capability Model. This is a model that I had built to help people understand how teams and a team's performance is influenced by the external system that they are a part of. So, in general, the Team Process Capability Model provides a means to understand how a team as a system, which they're involved, which includes social and technical system subsystems, have interactions influence team performance within a particular work domain. The work domain in general is what the team has been designed to do, what the purpose that it's supposed to do. For instance, if it's in an automobile facility, manufacturing facility, the work domain would be the work that is required to create a car. So the car would be the work domain. So I will go into that in more detail on this. So it provides a model for understanding how changes the social technical domain impact team performance over time. So we can use this model to understand how when we change either the social subsystem or the technical subsystem, how it's going to change performance. Subsequent papers that I'm going to write is going to talk about both the social and technical subsystems. So this is going to be an overview for this. And then it aids managers in understanding how decisions may impact a team's performance. A manager's decisions directly influence the resources that a team uses, and subsequently it affects how a team performs. I will again go over this in high detail. I will be providing subsequent videos and papers on all three of these, actually the social domain and the technical domain and the manager's influence. I'm going to design a cybernetic system which will be used to help monitor this social technical system as part of a team process capability model. So definitions, really quick. These are just four main definitions that I'm going to be using in this paper. So a social system, when I discuss a social system, it generally consists of individuals and their interactions. And it represents a team's ability to leverage competencies and expertise within the team. This is important because the social system is not just the people in the team, but how they are able to leverage each other's expertise. And in general, when we talk about competencies and expertise within a team, we look at how complementary and how directly related it is to the work domain. So a team's skill set as a whole, each person's skills should be complementary to everybody else's skills. It should complement everybody else. And it should be applicable to the work domain requirements. That's very important. So those are two general things that a social system requires for the individuals within that social system to be able to perform at a high level. The technical system consists of tools, materials, resources, processes, and procedures that are accessed by the social system to exploit environmental opportunities. It is the social system's interactions with the technical system which defines the work domain that they are able to exploit. So the work domain generally consists of interactions between the social and the technical system. So the social and technical system interact together to provide a capability to perform a certain task or achieve a certain goal. So, and this is usually defined by management when the team is designed. So when the team is designed, you say, okay, what is this team supposed to do? At that point, the management determines the social system elements that are required and the technical system elements that are required. And these interactions define how well the team will be able to work within a specific work domain, which is defined by management. And the team process capability is the team's ability to absorb environmental demands related to its work domain. So when we talk about a team's process capability, in general, this is the team's ability to work together with the social and technical systems interacting together to not only perform a certain task, but also to be able to absorb the demands related to its work domain as they change and in real time. So when we talk about the work domain, we're talking about a team's ability to perform to perform towards a certain goal. And the work domain can be applied to an environment to determine what percentage of the environment that team has been designed to exploit. And this is what I'm talking about right here. So when we look at this, we have the social system and the technical system, and they work together to provide a form of process capability. This is the team's ability to exploit the environmental factors that it is designed to exploit. And then this can fit right over the work environment to absorb that part of the work environment that relates directly to the process capability. So you can have a high process capability. It's similar to a capacity when we deal with operations, where you may have more capacity than you need or less capacity. And I will go into that in a little bit more detail. But that capacity or process capability in this instance it absorbs the work domain, which is the demand placed upon the process capability. So in many instances, what you may have is something like this, where the work domain may be greater than the process capability, than the social and technical system's ability to absorb, in which case you have undercapacity, where you're not able to address all of demand within an environment. And this can be applied directly to a supply chain or wherever. If the work domain requires, has the potential to sell 2,000 vehicles, but the social and technical system is only able to create 1,000 vehicles, then obviously we have an undercapacity. And the same is true with the opposite. You may have more process capability than is required to absorb the work domain. Okay, in which case we have an overcapacity situation. So this is kind of important as we look at the process capability model. Now, the process capability model, we've got the x-axis, which is the process demand here, and then we have the y-axis, which is process output. And as you notice, up to a point, as we create 1 unit of demand, we output 1 unit of demand. So we continually go up to a point, to the first point, which is called the requisite process capability. And what the requisite process capability is, it is the point at which the team can comfortably work at a constant rate without an impact to its performance. Okay, this is the maximum point where the team can work without fatigue or without any problems. Now, obviously, this can move back and forth based upon environmental conditions or things like if either the social system or technical system can change in either way. But in general, this is the sweet spot for all teams that all teams should strive to work towards. This is the point where you could work pretty much without any hesitation. Now, as we continue, you can see here how we're still going up and up until we get to the next point, which is the marginal process capability. And this is the greatest point in which we can still match the demand of the work domain. So at this point, as you can see, we have a process output. It still meets the process demand, but this is the highest point at which we can meet the demand with the process output. Now, you may think that this would be the requisite process capability, but actually teams that work in this region are actually working above their comfortable capacity. This is where you start doing things like overtime or whatever, to work beyond its sustainable limit. At this point, they don't have enough, for instance, they may not have enough time to repair the machinery. They may not have enough time to restock shelves. When they're at this point, a lot of the background tasks that are required for the social system to perform, to maintain performance, may be overlooked. Now, if we stay here for a long time, we start to see where our demand begins to continually increase, but our output doesn't keep up with the demand. And this is called the entropy area. In a system, the entropy area is a point in which we have more energy loss than we gain. In theory, all systems have entropy, but within this model, as long as you're within the requisite process capability, the team's able to absorb the entropy. Okay, I'm not going to go into entropy in too much detail, but just suffice it to say that this is kind of like lost energy that occurs. Like for instance, when you have a light bulb, the lost energy is the heat that comes off of it, or the power that comes off of it. So this is where the entropy exceeds the ability of the team to absorb it. So we keep going here until a point in which the team just can no longer continue at a high output. And this is the breakdown area. This is the breakdown area is like the point where the team begins to break down. People leave, systems, machines break down. In the case of a supply chain, you may have exceeded the supplier's ability to provide high quality parts. The parts they provide begin to have higher and higher failures. So this is the breakdown area. Now, this is a general mark here. This breakdown area could be very steep, and it could be very shallow, depending on the performance of the team and the system as a whole. If you have, like for instance, if you have a very robust supply chain, then this breakdown area may not be so bad, and this entropy area may be a lot less steep. But if you have a very inefficient supply chain or very inefficient manufacturing, this entropy area could actually be worse, and the breakdown area could be steeper. So it just depends on the social and technical system and the environment that it operates in. So on the side here, I have these marks here. When the team works below the requisite process capability, this is the overcapacity or overcapability or overcapacity. So basically, we have more capability than we need to meet the demand, the output. We have more output available than we need to meet the demand. So we're able to basically match the demand. Now, once you get past this, we have the adaptation region. The adaptation region is where the team actually has to flex its muscles to maintain its performance. A short-term performance in this region can actually be beneficial because it teaches the team how to work outside of its comfort zone. As I said before, prolonged operations within this region without any type of learning to take place to move this line up and to maybe move this line up as well can actually cause harm to the social technical system. Okay, so now once we get past this point, we have the undercapacity. Basically the system is unable to match the demands of the work domain, and as a result, we aren't able to fully exploit the external environment. So, and here's just the definitions. Feel free to pause it. I already talked about them briefly, but process output is the output of the process or the output of the team. Process demand is a level of output demanded by the system or by the environment, by the work domain. Marginal process capability is where the output meets the demand. It's the highest point where output meets demand. And the requisite process demand is the optimal performance level of the social technical system. Once again, you could raise this if you have a learning system in which the team can work with between the requisite and the marginal process capability, and it learns how to perform better. This can actually be beneficial, but prolonged operation in here without learning can be very damaging. So the entropy area is a point where your output is less than the demand. And this is the area in which process performance breaks down because the team is no longer able to absorb the entropy effects of the system. So this is a quick graph just to give you a link to when I was talking to the work domain under and overcapacity. In this case, we have overcapacity, in which the system currently forms the current level of demand is actually less than the maximum output. Okay, and this is just the opposite. We've actually exceeded the maximum sustainable output. We've actually passed the marginal process capacity, and as a result, we are actually suffering from high entropy effects. You can consider this like a diminishing return. As anyone who's ever worked overtime, you can work overtime for a little bit with a high level of performance, but eventually the level of performance relative to each additional hour begins to decrease, and that's your diminishing return. Very similar to this also. So this is a very general discussion about process capability. In subsequent papers and subsequent videos I'm going to make, I'm going to go into more details on the social system, technical system. I'm going to actually try to develop a way to measure this using a thing called Kingman's equation. And I'm going to basically break it down into using queuing theory to better understand how a team's performance is. So you can, as a manager, so you can see where this team is operating and how well they're operating, which of these zones that the team is currently operating in. And I will be sure to let everybody know when I do this. I have a website, curiousmanager.com. It's definitely still in work. But if you go in there and subscribe, I will definitely let you know when future papers on this are written. So, as always, please feel free to place comments on this video, and I check them frequently, so I will be more than happy to answer them or provide additional detail. Thank you very much for listening, and I will talk with you later.